For decades, psychology and neuroscience have operated on a standard assumption about why we dream, that the sleeping brain is actively trying to replay, process, and consolidate the specific events and stressors of our waking life. Early psychoanalytic models set this baseline. They attempted to draw a direct arrow between a specific waking stressor and a dream symbol. Even as later clinical approaches allowed for symbolic interpretations, the core methodology remained identical. To understand a dream, one must diagnose the original waking event. But clinical dream records reveal a paradox. If the primary goal of dreaming is memory consolidation, our dreams should be highly organized. Instead, dream journals are filled with severe discontinuity. We experience combinations of unrelated eras and physical settings that completely ignore waking reality. This split-screen comparison illustrates the core problem. We expect rigid, chronological waking memory on one side and a direct mirror image on the other. That exact one-to-one reflection does not exist. The rigid structure dissolves, replaced by a flow of emotional residues. Treating dreams as historical replays fails to explain their structural reality. To understand how the brain processes the night, we must examine the mechanics of neural strain and how it balances itself once external input stops. The Brain Kinematics Model offers a systems-oriented framework. It treats the brain as a dynamic, mechanical engine, constantly processing and balancing informational loads. Within this framework, dreams act as complementary activities to our waking states, rather than direct reflections of them. Every action, thought, and sensory input generates neural strain. When waking cognition is interrupted or incomplete, it leaves behind residual strain, the energetic and emotional leftovers of the day. To decode a dream, we have to analyze the physics of the unprocessed strain left behind by our waking interactions. Every incoming sensory input generates a flow of neural strain. This strain moves through a strict processing sequence. It enters as sensory input, transforms into perception, integrates into cognition, and finally prepares the body for action. This network diagram shows how neural pathways possess structural and functional resistance. Because of this resistance, the incoming load splits. Most strain is burned off through immediate action or reasoning. The remaining unintegrated load is adsorbed, clinging to partially activated memory networks. The waking brain is an imperfect engine. Every interaction produces a hidden, trapped energetic residue that the system must eventually balance. When we sleep, external sensory competition drops, and the prefrontal cortex relaxes its executive constraints. This topographic map illustrates how, in a quiet environment, the adsorbed strain finally unbinds and becomes mobile. Without reality constraining it, the flow is driven by memory gradients and theme attractions, converging along paths of emotional similarity, bypassing logical chronology. Waking texture is constrained by environmental reality. Dream texture is built from these mobile, residual emotional loads. A dream's bizarre landscape is the visual result of energetic strain following emotional contours rather than physical reality. We can observe this mechanic in the brother reunion case study. A person attends a family gathering and dreams that night of intensely crying and clinging to their brothers. This flowchart tracks the process. The gathering provided social satisfaction, releasing a portion of strain. The adsorbed residual strain was the unvocalized fear of aging and separation. The dream amplifies this hidden strain, processing the residue of future separation instead of replaying the event. Consider an opposition gathering dream, where a person argues with politicians, only to discover those politicians are completely ignoring him. This dream is not about political thoughts. The Brain Kinematics Model reveals that the residual strain operates purely on an axis of significance versus neglect. The literal setting and the characters of a dream are symbolic containers used by the brain to process these specific emotional tensions. This dynamic explains dream condensation, where unrelated daily events merge into a single cohesive narrative. Once strains detach from their sensory origins during sleep, they lose their identifying timestamps and physical contexts. This diagram demonstrates how strains merge if they share similar thematic textures. 3 distinct stones drop: a work conflict, a family conversation, and a childhood memory. Their ripples expand and intersect. The resulting interference pattern forms a unified residual strain field. We see this in a dream where a person is dismissed by a former boss. Their waking day contained publishing concerns, a moment of social exclusion, and project delays. These events all generated the same emotional ripple pattern of exclusion. The brain condenses all of these overlapping strains into a single, emotionally efficient avatar to process the load, the dismissive former boss. Condensation demonstrates the kinematic efficiency of the sleeping brain. By merging these overlapping interference patterns, the brain can route multiple residual strains through a single symbolic pathway toward a lower energy configuration. While dream settings constantly change, the underlying strain textures repeatedly cluster into distinct categories over time. This matrix outlines 4 structural balance axes governing residual strain: recognition versus neglect, connection versus separation, progress versus obstacle, and competence versus vulnerability. Random dream environments map here. Soaring or exams fall under competence, while a hospital maze processes the friction of progress. Recurring dream themes act as a diagnostic map. They reveal the architectural structures where a person consistently accumulates psychological friction. The original waking event never equals the dream. The Brain Kinematics Model views the mind as a dynamic system, constantly seeking equilibrium from its informational load. Within the BKM framework, dreaming acts as a critical maintenance phase, allowing the system to shed accumulated tension and reset its baseline for the following day. To understand the sleeping brain, we must look past the waking events and identify the specific tensions the dream is actively trying to balance. Dreaming is the necessary complementary continuation of reality's unfinished kinematic work.